Question number 1. Two functions are defined on suitable domains as f of x equals 2 plus 1 over x and g of x equals x squared minus 2x. These two here. Part A, evaluate g of f of 1/2, which is a composite function. So we'll write that down first. G of f of 1/2. So first thing I'm going to do is write down the g of x function that we're given at the top. And what we want to do here is substitute the f function into that, and into the f function we want to put 1/2. So we'll do a little bit of working over the side first of all, and we will work out what the function f of 1/2 is equal to. So f of 1/2 is equal to 2 plus 1 over, and instead of x on the bottom we have 1/2. That gives us 2 plus 1 divided by 1/2, which is 2 plus 1 multiply, and that means we need to flip the fraction upside down. Gives us 2 over 1, which means we have 2 plus 1 times 2 over 1, which is just 2, which gives us 2 plus 2, which equals 4. So that means f of 1/2 is equal to 4, which means if we go back up here, what we're actually trying to work out here, f of 1/2 is 4, so it's actually g of 4. So if we continue on, it's actually g of 4 we need to work out. So that means we have 4 squared minus 2 times 4. So that gives us 16 minus 8, which gives us 8. The answer to the first part. Moving on to part B, the question asks us to show clearly that the composite function g of f of a can be expressed in the form 2a plus 1 over a squared. So we want to substitute a into the f function, and then we want to substitute the f function into the g function. So we'll do this off at the side here. The first thing we want to do is substitute a into the f function. So first of all, the f of x function, the original function, is 2 plus 1 over x. We're looking for f of a, which will in turn be substituted into g. So f of a is 2 plus 1 over, and instead of x we have a. So what we're actually trying to find out is the composite function g of f of a. So g of f of a. So what we're going to do now is take the f function and substitute it into the g function. So before we do that, we'll write down what the g function was. The original function, g of x, was equal to x squared minus 2x. So that means where we see an x in here, we're going to substitute it with the f of a function, which is this one up here. So if we do that, we first of all get, instead of x squared, we get 2 plus 1 over a squared, and then it's take away 2 times x, which we then replace again with 2 plus 1 over a. So in order to do that, we have to square out this bracket, so that's 2 plus 1 over a multiplied by itself. Take away 2 times the second bracket, so negative 2 times 2 is negative 4, and negative 2 times plus 1 over a is negative 2 over a. So that then gives us 2 times 2 plus 1 over a plus 1 over a times 2 plus 1 over a. To multiply the brackets out, take away 4, take away 2 over a. So first of all, 2 times 2 is 4, plus 2 times 1 over a is 2 over a. Then plus 1 over a times 2 is 2 over a again. then 1 over a times 1 over a is 1 squared over a squared. Take away 4, take away 2 over a. So we have a plus 4 and we have a minus 4, which will cancel each other out. If we collect together the like terms, we might be able to see what happens next. Well, in fact, before that, we have a plus 2 over a and a minus 2 over a, so they can cancel out. So in fact, what that leaves us with is 2 over a and plus 1 squared over a squared, which is just 1 over a squared. Now, we're trying to show what was written at the top of the page, which is slightly different from this. It's just a single fraction, so we need to try and combine these two fractions. At the moment, they have different denominators. If we simply multiply by a on the top and the bottom, that will give us the required common denominator of a squared. So that would be 2a over a times a, which is a squared, on the bottom of this one, plus 1 over a squared. Putting them together, that gives us 2a plus 1 over a squared. That's what we set out to do, so that's the end of our question. Question number 2. Triangle PQR is right angled at Q, it's here, and has vertices P 3,11, Q minus 3,7 and R 5, K, where we don't yet know the value of K. M is the midpoint of the line QR. Part A, use gradients to establish the value of K. So from the diagram we can see that the line QP and the line QR are perpendicular, which means if we know the gradient of the line QP, we can easily work out the gradient of the line QR. If we know the gradient of the line QR, then using the gradient formula, we can then establish the value of K. And that's what we're going to do first. So we'll just put this out of the way for the minute, which gives us, well, we'll put our points down first of all. We've got point Q, which is negative 3,7, and point P, which was 3,11. So that will be our x1 and our y1 and x2 and y2. So to work out the gradient of the line QP, it's y2 minus y1 over x2 minus x1. So substituting in our values, that gives us 11, take away 7, over 3, take away negative 3, which then gives us 4, over 6, which then simplifies to 2 over 3. So now we know that the gradient of the line QP is 2/3, which means the gradient of the perpendicular line QR will be that number flipped upside down with the sign changed. So that means that MQR is equal to negative 3 over 2. So now that we know that, we can use the gradient formula to work out the value of K. So the 2 points on the line were Q minus 3,7 and R, which is 5, K. So that will be our x1 and y1 and x2 and y2. So the gradient of the line QR using the gradient formula is y2 minus y1 over x2 minus x1. We already know the gradient of QR is negative 3 over 2, and y2 is k, take away y1, which is 7, over 5, take away negative 3. That gives us negative 3 over 2 equals k take away 7 over 5 take away negative 3, which is 5 plus 3, which is 8. To get rid of the fractions, we can simply cross multiply here, which gives us minus 3 times 8 equals 2 times k minus 7. Minus 3 times 8 is negative 24. 2 times k is 2k, and 2 times negative 7 is negative 14. So write that the other way around. 2k minus 14 equals negative 24, which means 2k equals negative 24 plus 14, which means that 2k equals negative 10, which means that k equals negative 5. That's what we're trying to do for part A and the answer to that part. Moving on to part B. In this part of the question, we're asked to hence find the equation of the median PM, which is this line here. So to find the equation of any straight line, we need the gradient and a point. And looking at the line here, we can see that we do have a point. We have the point P. But what we don't have is we don't have the gradient of this line. Now, the word hence is used, which means we're going to use something that we did in part A. If we look at part A, what we were trying to do is establish the point, the letter K, the value of K. We have now done that. That means that we have these 2 points, Q and R, which means we can then work out the midpoint, which is point M, for this line. If we can work out the midpoint M, then because we have point P, it means we can work out the gradient of the median, the line we're trying to find. Once we have the gradient, we then have a point and the gradient, which means we can work out the equation. So we'll go ahead and do that. So we'll remind ourselves the 2 things that we actually need. We need M, the gradient of the line, and we need a point on the line. So we have a point in the line already, that's the point 3, 11. M, the gradient, is the thing that we're going to try and work out first. Okay, so the 2 points we're looking at, Q and R, negative 3, 7, and 5, minus 5. Those 2 points can be used with the midpoint formula to work out the midpoint M. So this is x1 and y1, x2 and y2. So the midpoint M, we use capital M, is the endpoints x1 and x2 from our endpoints divided by 2, and the y value is the y values from the endpoints added divided by 2 also. So substituting our values in, we have minus 3 and 5 divided by 2, and 7 plus negative 5 over 2. That then gives us 2 divided by 2, and 2 divided by 2 again, which then tells us that the midpoint is the point 1, 1. So now that we have the midpoint, what we can do is we can use the midpoint along with the other point we know on the median, which is the point P. So we'll write that down here as well. That was 3, 11. So if we label these points x1, y1 and x2, y2, then we can use these points to work out the gradient of the line using the gradient formula. So M, the gradient of the line MP, is y2 take away y1 over x2 take away x1, which is 11 take away 1 over 3, take away 1, which then gives us 10 over 2, which is 5. So what we have now is the gradient of the line. That's what we were looking for. So going back to the question up here, we now know that m is equal to 5. We already had a point on the line, so we can use these facts to use the gradient of the equation of a straight line formula now to work out the equation of the median. So do that over here. Y minus b equals m bracket x minus a. So that's y take away 11 equals the gradient m, which is 5 times x minus 3. That gives us y minus 11 equals 5x minus 15. Collecting that all to the one side would be y minus 5x minus 11 plus 15 equals 0, which means y minus 5x plus 4 equals 0. This is the equation of the median and the end of the question. Question number 3. The diagram shows the graph of y equals f of x. The function has stationary points at 0, 0, 2, minus 8 and 5, 0 as shown. Sketch the graph of the derived function y equals f dashed of x. So the first thing we'll do is zoom in and we'll just draw right on top of this picture here. So we have to remember the technique to use here, which is that the stationary points on the original curve represent the points where the derived function, the differentiated function, crosses over the x-axis. So the easiest way to see that is with this one to begin with. This is one of the stationary points in the original function, but what that indicates is it gives us an idea of where the derived function will cross over the axis, which means it's going to cross over here at the point 2. So the other ones, the stationary points, are already on the axis, which means here the derived function will pass through the x-axis here, and for this one the derived function will pass through the axis here. So that's 5 and that one is 0. So to find out the shape of the graph, we look at the gradient on the original graph. So on the original graph, to begin with, we have negative gradient here, so we show that using negative signs on the original graph. It has negative gradient here because we have a point of inflection here, so the gradient stays negative after the stationary point. Then we have a minimum turning point, which means the gradient changes to be positive on this part of the curve. Then we have another stationary point and it's a maximum, which means the gradient on the original curve becomes negative again. Now on the derived function, the plus signs and minus signs mean something else. What it means, negative signs mean below the x-axis and plus signs mean above the x-axis. So we're going to sketch approaching from the left. So the original curve is negative up until the first red dot, which means the derived function will be below the axis up to the first red dot. Now we would expect it to cross over the x-axis and become positive here, but if we look at our original function, it stays negative, which means the derived function must stay under the x-axis, which means when it gets to this point here, it doesn't actually cross over, it must just curve and come back downwards. Now what we also can see is that the derived function will have to pass through this point here. So that means we're going to have to turn around and go back upwards. So there's no way of clearly identifying how far down it will go. So we'll put our curve there and we'll sketch it up towards this point. Now, On the original graph, the point indicated here tells us that the original curve changes to positive gradient. Now on the derived function, that means at this point here, it changes to being above the x-axis. So since we have another point where the derived function has to pass through here, that means again our function has to curve round and come back downwards. Now, on the original function at this point, the gradient becomes negative, which means on the derived function it passes through and goes underneath the axis. So it's not a perfect sketch, but that's how it looks. You have to quite clearly indicate any points on the derived function that you know, and we have done that. The point 5, the point 2, and the point 0. So this is y equals f dashed of x. Question number 4. A recurrence relation is defined as un plus 1 equals a times un plus b, where a and b are constants. Part A, given that u1 equals 100, u2 equals 80, and u3 equals 66, form a system of equations and solve it to find the values of the constants a and b. So this question is actually quite straightforward. It actually tells you to form a system of equations. Many of the questions of this type don't tell you that. So we know we need to use simultaneous equations before we even begin. So we can set up two separate equations using the information we're given. First of all, if we use u3 equals a times u2 plus b, we can get an equation because we know u2 and u3. And if we use the other one with u2 at the front, u2 would be a times u1 plus b. That will give us a second equation since we know u2 and u1 also. So u3 is 66 equals a times u2, which is 80, plus b. And the other one, u2, which is 80, equals a times u1, which is 100, plus b. So simplifying what we have here, we have 66 equals 80, a times 80, which is 80a plus b. And on the other one, we have 80 equals 100a plus b. We want to solve for a and b. Now the easiest way to do this, rather than setting out the way you would traditionally do simultaneous equations, maybe at a lower level, is that we can hopefully spot that this can be rearranged to make b the subject. So 80a plus b equals 66. That's just swapping the sides around, which means that b is equal to 66 take away 80a. Doing something similar with the other one, we get 100a plus b equals 80 by switching the sides round, which then means b equals 80 take away 100a. Since we know that both equations have b as the subject, that means we can make both of these equal to each other. So we have 66 minus 80a, which is b, and we can make that equal to the other b, which is 80 minus 100a. That eliminates the b's, which means we can rearrange and solve. So bringing 100a to this side changes it to plus 100a, take away 80a. And we have 80 on this side, and taking 66 over makes it become negative 66. 100a take away 80a is 20a, equals 80 take away 66, which is 14. So that means a equals 14 over 20. That can be simplified to a equals 7 over 10, which means that A equals 0.7. What we need to do now is find B. So we can take 0.7 and substitute it into one of the equations that we had earlier. So we use the one B equals 80 minus 100A. Doesn't matter which one you choose. So that means B equals 80. Take away 100 times A, which we now know is 0.7. So that's B equals 80, take away, and 100 times 0.7 is 70, which means B equals 80 times 70, which is 10. So we've got the two values that we needed. A is 0.7 and B is equal to 10. Going back to the question. Question part B, hence explain why this recurrence relation has a limit as n tends to infinity and find the exact value of the limit. So moving to the side here, we have found out that A equals 0.7. The definition for a limit to exist is that A has to lie between -1 and 1. Since A is 0.7, that therefore means that a limit exists. That means we can go ahead and calculate the limit, which it asks us to do. Using the limit formula, L equals B over 1 minus A. So that means our limit equals B, which we found to be 10, divided by 1, take away 0.7. So that means our limit, L, is 10 over 0.3. Multiplying by 10 on the top and the bottom here gives us a fraction we can work with. So that's 100 over 3. 100 over 3 is 33 and a third. That's the exact value of our limit and the end of the question. Question number 5. A function is defined on a suitable domain as h of t equals 1 over t multiplied by 2t minus 3 all squared. Find the rate of change of this function when t equals 3. Now, the mistake that people make at this point is to substitute 3 into the function that we're given. The rate of change means that we want to differentiate first. So what we need to do first of all is prepare what we have for differentiation. So we'll just write down what we have first of all. We have h of t equals 1 over t bracket 2t minus 3 all squared. So to prepare this for differentiation, we'll first of all multiply out the squared bracket. So 1 over t, we'll put that outside a square bracket and multiply by that later. We have 2t minus 3 all squared, so that's 2t minus 3 multiplied by itself. So we have 1 over t multiplied by these two brackets multiplied together. So that's 2t multiplied by 2t minus 3. And then minus 3 times 2t minus 3. So we have our 1 over t out at the front. Keep that there just now. 2t times 2t is 4t squared. 2t times minus 3t is minus 6t. Then minus 3 times 2t is minus 6t again. Then minus 3 times minus 3 is plus 9. We can simplify the inside of the square bracket before we go any further. So that's 4t squared minus 6t is minus 12t plus 9. And now we're going to multiply through by the 1 over t. So 1 over t times 4t squared is 4t squared over t. take away 1 over t times 12t, which is 12t over t, and then 1 over t times 9, which is 9 over t. What we can do now is simplify. So the t here will cancel with the t here. The t on the bottom cancels with one of the t's on the top. And 9 over t can't be cancelled at all, but the t will be brought up onto the top line in preparation for differentiation on this line. So we have 4t, then we have take away 12, bringing the t up alongside the 9 makes it 9t to the power minus 1. So what we have now is something that is ready to be differentiated. So this in fact is still our h of t function. So we'll write it down like that, 4t minus 12 plus 9t to the power minus 1. So if we differentiate, it's h dashed of t equals 4t. When we differentiate, it just gives us 4. Take away 12 just disappears completely. And then that's minus 1 on there. Minus 1 comes down as the multiplier, which gives us minus 9t to the power minus 2 when we subtract 1. So what we're trying to find is the rate of change. So that was the derived function when t was 3. So we're going to substitute t in, but before we do that, we'll try and leave our expression with a positive power. So h dashed of t, the derived function, is 4 minus 9 over t squared. We want to know when t is 3, so substitute in, we have 4 take away 9 over 3 squared, which gives us 4 take away 9 over 9, which gives us 4 take away 1, which is 3. So the rate of change of the function at t equals 3 is 3. Question number 6. Solve algebraically the equation 2 cos 2 theta plus root 3 equals 0 for angle theta lying between 0 and 2 pi radians. So in order to make this a little bit easier to work with, we'll first of all convert our interval that we're working with into degrees, which means theta is actually going to lie between 0 and 360 degrees. Now if we look carefully at our equation, we can see it's actually 2 theta in here, which means we should rewrite our interval to make things simpler. That means our answers will come between 0 and 720 degrees in the first instance, just by doubling 0. 2 zeros are 0, and 2 times 360 is 720. Writing down the equation that we're going to solve, it's 2 cos 2 theta plus root 3 equals 0. So rearranging, we get 2 cos 2 theta equals negative root 3, which means that cos 2 theta is equal to negative root 3 over 2. So we can use our exact values table here to work out our associated acute angle. Ignoring the negative sign, we know that root 3 over 2 is 30 degrees when working with cos. So using our associated acute angle, we can now draw our cast diagram. So put that at the side. Our quadrants are all sine, tan and cos. Since we have a negative, that means we are working with the sine and the tan quadrants, which means the angle we'll be looking for is the one in here, 180 take away 30, and the one in here, 180 plus 30. So our angle, I'll move this up slightly, 2 theta, 180 take away 30 is 150, and 180 plus 30 is 210. A rewritten interval means that we can go all the way up to 720. So to get more values, you just take your initial two values and you add 360 to each of them. If it's still within the interval, then we're okay. So 150 add 360 is 510, which is within the rewritten interval. And 210 plus 360 is 570 degrees. Now we could go on and find more values by adding 360 to these two, but that takes us out with our interval. Now, our original question was written in radians, or was asked in radians. That means our answer should be in radians as well. The easiest thing to do is to convert to radians at this point. So 2 theta equals 180. Well, pi is, this is 150. Pi is 180 degrees. So if we divide that by 6, then pi over 6 is 30 degrees. And that means 150 degrees is 5 times that. So 150 degrees is 5 pi over 6. For 210 degrees, that's 7 times 30 degrees, which is 7 pi over 6. 510 degrees is 17 times 30, so that's 17 pi over 6. And 570 is 19 times 30, which is 19 pi over 6. So we want to solve for theta, which means we have to divide each of our values by 2. So 5 pi over 6 divided by 2 is the same as multiplying by 1/2, which gives us 5 pi over 12. Similarly with the second one, that gives us 7 pi over 12. When we divide by 2, 17 pi over 12 and 19 pi over 12. These answers all lie within the original interval, which was set to be between 0 and 360. Our answers are now in radians, which means these are the final answers. Question number 7. Part of the curve with equation y equals x cubed minus 3x squared plus k, where k is a constant, is shown below. The curve has stationary points on the axis at A and B. Part A of the question asks us to find the coordinates of the stationary point B. So that's the one on the x-axis. In order to find the coordinates of any stationary points, we must differentiate and set the derivative equal to 0. So the curve has equation y equals x cubed minus 3x squared plus k. Now initially you might think that k will pose a problem, but as we discover, when we differentiate, dy by dx equals x cubed differentiated is 3x squared, negative 3x squared differentiated is negative 6x, and then when you differentiate k, well k is a constant number, and when you differentiate a constant number, it just disappears. For stationary points, we must set the derivative equal to 0 and solve. So 3x squared minus 6x equals 0. We want to do now is solve that, and we do that by factorising. We will take a common factor out of this one, of 3x, which leaves us with 3x bracket x minus 2 equals 0. So what that means is that either 3x equals 0 will give us a stationary point, or x take away 2 equals 0. So it's 3x equals 0, that means x would be equal to 0, or x take away 2 equals 0, which means x would be equal to 2. Now, studying the diagram should tell us that the one we're looking for, the stationary point B, is the one with an x value of 2. The other stationary point quite clearly has an x value of 0, so the one that we want is this one here. Since it's on the x-axis, we know that the y value must be 0, which means the point B, the one we're asked about, is the point 2, 0. And that's the end of part A. Moving on to part B. Hence, establish the value of k and write down the coordinates of the other stationary point A. So we have the equation of the curve, y equals x cubed minus 3x squared plus k. So we'll just write this down. Y equals x cubed, minus 3x squared plus k. So what we have now is we have a point lying on the curve. We now have the point B, which was 2, 0. So we can substitute the x and the y value in order to find k. So y is 0 when x is 2, so that's 2 cubed minus 3 times 2 squared plus k. So that's 0 equals 2 cubed, which is 8, minus 3 times 2 squared, which is 4, plus k. So that's 0 equals 8, take away 3 times 4, which is 12, plus k. 8 take away 12 is negative 4. So 0 equals negative 4 plus k, which means that 4 equals k, and therefore k equals 4. That's the first part of the question. It said find k and then go on and find the other stationary point A. So we have our k value equal to 4, which means we can now write the full equation of the curve down without the unknown k. So that's y equals x cubed minus 3x squared plus 4. So the point we're looking for is the point A. We know it's on the axis as well. We know it is on the y-axis, which means the x value is 0. And all we need now is the y value. It's fairly straightforward to do this. We just substitute in. So y is going to be x cubed, which is 0 cubed. Take away 3 times 0 squared plus 4. So the 0 parts cancel out, which just leaves us with y equals 4, which means the other stationary point is the point 0, 4. And that's the answer to part B.